Hi there. I'm Alexander Kulik from Consensive, and I'm happy to present some joint work with Darmstadt Graphics Group, where we use their RapidPipeline to create a new format for output-sensitive 3D data streaming. That format is called GLoD, and we use it to provide large model social mixed reality across locations and devices. As a background, Consensive builds social mixed reality applications with digital twins of real-world places and machinery for various applications. Don't want to dive deeper into that. But all of these developments built on three unique software modules, of which I want to dive deeper only on output-sensitive 3D data streaming. In combination, however, with cross-platform distribution and interactive behavior models, that creates a content management system for large model social mixed reality. So we offer the software modules for partners who want to build their own applications on it. We build bespoke applications for clients on this basis, and we also create turnkey systems that can be readily rolled out at museums, at trade fairs, or training centers, wherever the functionality is needed. To dive a bit deeper into GLoD, the concepts of output-sensitive rendering, out-of-core data streaming are known. It allows us to display models that are of any size that wouldn't fit into memory and couldn't be rendered in real time on mobile devices. It allows us to do that by making sure that the resolution stays almost constant across the display, independent of the data behind. So here's the short video illustrating how that works. As we approach the tower, the resolution, both in triangles and in texture, increases as we get closer. And we see this also in terms of the edges of the triangles that are visualized here in the Unity scene editor view. As therefore, from this overview, we can see wherever it's darker, there is a higher resolution because we render more edges of these triangles. And that works quite well for 3D photogrammetric 3D reconstructions. For cut data, we need to apply a slightly different approach, where here we apply importance culling that simply leaves away small details that would otherwise that wouldn't even be visible, because the geometries themselves often cannot be collapsed any further. The result is similar wherever we look. We get a higher resolution, and that format supports also multi-texturing. Therefore, a physically based rendering is possible. The pipeline to create such experience starts with the models from our clients, which we subdivide into semantic submodels. And if these semantic submodels are still too large, then we create our level of detail structure that we call GLoD. And that's where RapidPipeline kicks in to offer a very high quality optimization of this new format. The GLoD data is then stored on online storage and delivered via a content delivery network to any client application that runs our Unity runtime, which is a C# assembly available if you're interested, and we cache the data locally to minimize network traffic. The GLoD builder is where we use RapidPipeline. So this is an illustration of a level of detail hierarchy. The leaf levels are simplified to parent nodes that become more reduced and more reduced the higher we get up in this hierarchy. And that's where RapidPipeline helps us to create a very high quality representation that is still simplified, and it ensures boundary preservation and also appearance preservation. And the latter is particularly difficult if we compare it to the open source Nexus format. Kudos to Federico Poncio, who really kicked off this development from my point of view with his milestone PhD in 2008. That Nexus format is open source available and it's quite good. However, at higher levels of this hierarchy, of the level of detail hierarchy, we see quite some distortion in the representation of the models, and that's due to incorrect texture reparameterization. RapidPipeline does that correctly, hence the GLoD format looks much better at a similar triangle count. So all of that together enables us to provide very large and high detailed 3D models across devices and across locations. So that, for example, we can meet in digital twins of cultural heritage places, or look at infrastructure together. We can create media stations that scale nicely and resource efficient, because rendering happens on these devices. So if we want to support more users, we simply buy a few more headsets. We don't need to scale up our online infrastructure. Everything happens on, every processing happens locally. And that also allows us to port such installations anywhere. We basically just need a little bit of internet to do to create that online connectivity, and then we can meet in these digital twins, not only of cultural heritage, but of course also of machinery. Here for CAD models, it's a bit different. First of all, it's important that these models behave, because we use them for training, and we want people to learn how to operate these machines. But it's also important that the representations of these machines is correct. And that's what we achieve with RapidPipeline. So to sum up, VR for More Data is our Unity runtime for the GLoD format. It offers the 3D data streaming with out-of-core data management, load balancing, adaptive level of detail, static occlusion culling. It's available for BRP and URP, and if you're interested to use it in your own projects, please reach out. We have an example project available, and if you just want to test it, here's a demo application that you can readily use. Thank you for your interest.